All right, welcome back. So today we are going to finish naming all of our organic compounds, or in this case right here, our hydrocarbon derivatives. So we're going to start with the alcohols just for right now. So an alcohol is an organic compound that has one or more hydroxyl functional groups. So hydroxyl is the covalently bonded OH, so it's not hydroxide. So normally what we see right here is a hydrocarbon chain, and we're going to see the hydroxyl group at the end, and we're going to realize that we're dealing with alcohols because the suffix or the ending, we're going to see OL. Now for naming our alcohols, they're basically treated almost the exact same as alkenes and alkynes. So the parent chain must contain the hydroxyl group. All right, so that is a must. So if you have multiple hydroxyl groups, it still needs to contain every single hydroxyl group that's there. And the chain is also numbered so that the hydroxyl group gets the lowest number possible. So just like the alkenes and the alkynes, where carbon 1 was always closest to the multiple bond, now we are going to get carbon 1 as closest to the hydroxyl group as possible. So alcohols are named from the alkane parent chain. So the E from the alkane name is dropped, and we add the suffix OL. So we kind of name it like it's an alkane, drop the E and add OL. So we will need to also put in a number where the hydroxyl group is located. And if there's more than one hydroxyl group, we have to use the di, tri, tetra prefixes as well. So let's look at our first example. So we can tell right here this is going to be a cyclohexane. All right, now of course when we start naming it, I know I'm going to have to drop the E and add OL. But before I kind of get into naming everything else, I do need to find carbon 1. So just like in cyclic alkenes and alkynes, carbon 1 and 2 always had the multiple bond. We are going to use that rule that we have to get the hydroxyl group on the lowest number possible, so that means that's going to get carbon 1. And then of course I'm going to number it so that the branches get lowest numbers possible, and we have to go around like this. Now as for our branch right here, we can tell this is a methyl branch. So that's kind of it. Now we're actually ready to name it. So we're going to start by naming our methyl first. So branches always get numbered first, or named first, sorry. So we have our methyl on carbon 3. So this name is going to start with 3-methyl. Now we name it like it's an alkane. So it will get cyclohexane, but from our rules, we drop the E and we add OL. So we got 3-methyl cyclohexanol. Now I'm not putting the location of the hydroxyl group in the name right here, because just like our cycloalkenes and alkynes, it is assumed that the functional group is on carbon 1. So in this case right here, it's assumed carbon 1 is going to contain the functional group. Now for our straight chained. Now you will notice that if you do find your longest continuous carbon chain, you're going to find this one right here as your longest continuous carbon chain with 1, 2, 3, 4, 5, 6, 7 carbons. Now a problem if you did this, you'll notice that we have a carbon right here and it has a hydroxyl group. So right now we're breaking one of the rules and saying that we need to make sure that the hydroxyl group is in our longest continuous carbon chain. So because of that rule, we're going to have to find our longest continuous carbon chain right across the middle here, containing carbon 1, 2, 3, 4, 5, and 6. So we actually have a hexane. Is our longest continuous carbon chain. And the reason for this, once again, we need to get our hydroxyl groups in our parent chain, our longest continuous carbon chain. And of course I did start numbering over here with carbon 1 because I can get the hydroxyl right on carbon 1. So I'm kind of satisfying both rules right here. And we'll notice that once I do all this, there is only one branch. And that is an ethyl branch right here. So remember, the hydroxyls are not branches. These are functional groups to tell us that we have an alcohol. Now, as for the naming, just like all the organic molecules before, we start by listing all of our branches. So ethyl first. So the name starting with this one is 2-ethyl. All right. Now, when we are labeling our longest continuous carbon chain, we name it like it is a normal alkane. So we have hexane. Now, normally we would drop this E and add OL. However, we do need to put in where these hydroxyl groups are located. So we do need to pay attention to this little note right here. If the suffix starts with a vowel, so that is the parent name, we drop the E. The suffix, that's like, in this case here, the suffix, the ending will be OL. So if the suffix starts with a vowel, we drop the E in the parent name. If the suffix starts with a consonant, we keep the E. All right, so where we have 2 hydroxyl groups right here, this is going to be a diol. So diol starts with a consonant, so we keep the E. And we have hydroxyl groups off carbon 1 and 3. So we have 2-ethyl hexane 1,3-diol. So and this is where we have our parent chain right here, the hexane, and our suffix, the ending, the OL. Now, if there's only one, we don't need to write that diol, but because there are 2, okay? So that's where you just had to be careful with the naming for some of these here. Now, this one right here, if you have benzene with the hydroxyl group, normally this is where I'd say, okay, try to figure out the name. But this one here is actually one that you just have to memorize. And that's if you have a benzene or an aromatic with the hydroxyl group, it's called phenol. And there's no other way around it. You just need to have that memorized, right? So whatever other name you think it might have, don't call it that. It's just going to be phenol, Phenol. All right, so even when you're saying that name, really try to pronounce that OL so you don't get confused with phenol, Phenyl. Now for this one right here, so it is another cyclic alkane one. Pause the video and give this one a try, because I'm going to put the answer up, well, right now. So we are going to use the same rule where carbon 1 needs to go on the hydroxyl group, and then we're going to start labeling them going around to try to get our branches off the lowest numbers possible. So it has to look like that, where we only have 2 methyl branches, and they are on carbons 2 and 6. So we go 2, 6 dimethyl. Oops, that should be an L. Cyclohexane. Cyclohexanol. All right, now as for the next 2, same thing, just pause the video, draw them out, and I'm going to put the answers up in 3 seconds. And that's what these will look like. So our 2-methylbutene 2,3-diol will look like this, and our 2-methylpropan-2-ol will look like that. All right, so those are the alcohols. So same thing, go into your workbooks and try some of those. If not, let's continue on with our carboxylic acids. So our carboxylic acids have a functional group that looks like this. Now, just so inside here, it actually, the carboxylic acid functional group, so the carboxyl functional group has a combination of 2 different functional groups. So the C double bond O is called a carbonyl functional group. And this OH, well, we just learned this one, hydroxyl functional group. But when we have the combination of 2 of them together, so the carbonyl and the hydroxyl, these combine for our carboxyl functional group. So you can see the carb part comes from the carbonyl, and the oxyl part comes from the hydroxyl, so we basically kind of sandwich those 2 words together, the carbonyl functional group and the carboxyl. Now, when we're naming our carboxylic acids, these are probably one of the easier ones to actually name, because there's going to be no no second guessing where carbon 1 is, because we are going to count our longest continuous carbon chain, including the carboxyl functional group, obviously. And this is the important one here. Numbering begins at the carboxyl group, and that is carbon 1 every single time. Now, how we name it, we drop the E from the alkane name and add the suffix oic acid. All right, so let's have a look. So we can tell our first hydrocarbon chain is right here. Now, right away, I see the carboxylic acid function group right here, so I know carbon 1 has to be stuck right here in the middle. Next is just finding my longest continuous carbon chain after that. So I go 2, 3, 4, 5, and 6. So my longest carbon chain is going to be hexane with a branch up here. That is ethyl. So for naming it, we name our branches first. So our carbon 4, we have ethyl. And now, normally, like I said, the longest continuous carbon chain is hexane, so that would be the parent name. But in order to name it, because it is a carboxylic acid, we drop the E and add oic acid. So that is what we're going to do right now. Drop the E and add oic acid. So we have 4-ethyl hexanoic acid. So of course with these here, they can get a little more complicated. Like for example, this one right here, you can pause the video and try the names on your own, or you can just follow along with me right now. So right away we see a carboxylic acid functional group, or the carboxyl functional group right here, so that gets carbon 1, and we go carbon 2, and carbon 3, and that's as many carbons as we can get. We can't go into the benzene ring here, because just remember, when benzene looks something like this is a branch known as phenyl. We have a chlorine or a chloro, and we have a methyl. So this name is going to be rather long, so make sure you do have enough space to write this in. But we also have to remember that we have to name everything in alphabetical order. So C comes before M and P in the alphabet, then M is next, and then P, right? So we're going to name the chlorine, methyl, and then phenyl. So our chlorine is off carbon 3, so we start with, I'm going to start over here, 3 chloro. Then we have our methyl, 2 methyl. Then we name our phenyl. So these are just all the branches. So 3 chloro, 2 methyl, 3 phenyl. Now our longest continuous hydrocarbon chain is only 3, so normally it'd be propane, but we drop the E and add oic acid, so we get propanoic acid. And that is its name. So 3 chloro, 2 methyl, 3 phenyl, propanoic acid. All right, so we do have a few other ones here. So practice some drawing, and then of course practice some naming. So I'd like you guys to kind of draw these here on your own, see if you can get them, and I'm going to put the answers up in 3 seconds. All right, and the answers look something like this. So we have our 4-iodobutanoic acid. Looks like this, so we can tell there's 1, 2, 3, 4 carbons long. So that's where we get our butanoic acid. And of course, our benzoic acid is right here. So notice we just draw our benzene, and we have our carboxyl functional group off on the side. Now you're going to notice whenever we have cyclic compounds as well, it's going to look like that. So you focus on this is the parent chain right here, and we do have our carboxyl functional group off on the side. So same thing, pause the video, see if you can get the names right here, because I'm going to put the answers up in 3 seconds. Alright, and that's what these look like. So we have our 3-chloro-4-methyl benzoic acid. So it still ties into, it looks exactly like the one I drew up there. So we do have our benzene as the parent with, of course, carboxyl function group off the end. And then our second one here, we got our 6-bromo-2-methyl hexanoic acid, and that is the numbering and everything like that there. All right, so our last family we're going to look at is our esters. So this is our last one right here, and probably one of the more difficult ones to name. So you will notice if we have an ester, because it's going to look like this. So we have two different hydrocarbon chains, and right in the middle right here, this is called our ester functional group. All right, and the suffix for our esters, you're going to know that you have an ester just from the name because you're going to see the O8 at the end. Now the reason that these are just a little more difficult for naming is because we have two different hydrocarbon branches right here. So we will have to name hydrocarbon chain attached to the oxygen first, and that is considered a branch. So our first thing right here is that the first part of the name is the alkyl group, the branch that came from the alcohol. So when we actually get into organic reactions, that'll make sense because we need an alcohol to react in order to do it. So basically what it's saying right here, this one right here comes from the alcohol, and we're going to have to name that first. Now the parent chain must contain the double bonded oxygen. So that means that it comes the carbon with the double bonded oxygen, where we drop the E from the alkane name and add O8 at the end. Now, we had to remember that branches on esters still follow alphabetical rules. Numbering begins at the oxygen end of the branch and the C double bond O end of the branch as well, or the parent chain. So that's just one little thing that you do have to remember, is that this one right here is considered our branch, and this one right here is considered our parent. So let's actually look at naming a few anyway, and we'll just see how it works out. So we have our first one right here that we can see. Now, as I kind of mentioned before up there, the hydrocarbons, or the carbons attached to this oxygen right here, so that means this part right here is considered my branch, and all this down here is considered my parent chain. So with regards to our branches, well, we are going to have to just name them like normal. So we've still found our longest continuous carbon chain. So carbon 1 needs to be the one attached to the oxygen. So we go carbon 1 right here, and then I can either go right or I can go down to get carbon 2. So there's my longest continuous carbon chain. Now the thing is, we'll notice that my longest continuous carbon chain did not include this one down here, right? Because this is still going to be considered a methyl branch. So you'll notice we have a branch in our branch, which is kind of weird, but how we actually name this is not too bad, because we're still going to keep all of our naming rules in place. So we name our methyl first. So we go methyl. Now normally we would go, it'd be methyl ethane, right? Because we have two carbon chain. But the reason we classify this one as a branch, because we're not going to call it methyl ethane, we're going to call it methyl, drop the A and E ending, and remember all branches have a YL ending. So we're going to end up calling this one methyl ethyl. Now I could put one methyl ethyl if I want to, because on carbon 1, but we know if it can't be on carbon 2, because that's going to increase the carbon chain. So that's actually our branch labeled, methyl ethyl. Now we move on to our parent chain. So our parent chain consists of 1 carbon, 2, 3, 4, and 5, where we have our branches of chloro and methyl. So let's name it just like normal. So pretend it's just like every other organic thing that we had so far, where we on carbon 2 we have a chloro, on carbon 4 we have methyl. Now, and our longest continuous carbon chain is 5. So it would be pentane. But remember, for our esters, we drop the E ending and add O8. So here's our name. We got methyl ethyl, 2-chloro-4-methyl pentanoate. I know, it's kind of long, but that's where we kind of get into that naming system now. I did kind of create another longer one for you, but when we get down to our examples of drawing them out, these are kind of more on the level that you're kind of expected to draw, like just ethyl 2-methylbutanoate, and then you got methyl propylbutanoate. Now, there is a typo here. It should be 1-methyl propylbutanoate, and try to draw that one. But either way, I'm going to give you 3 seconds. I'm going to put up the drawings and the name for this one up here. Alright, and these are the answers. So we have this long one up here. I did label this branch in green first, so we can tell off carbon 3 we had a methyl off a 4-carbon chain branch. So we got 3-methyl-butyl. Then our parent chain is 5 carbons long with an ethyl off carbon 2, so we label that one as 2-ethyl pentanoate. Then of course when we get to our drawings, we have ethyl 2-methylbutanoate. So we have our 2-carbon chain off our oxygen right here, so that's where that ethyl came from. And the 2-methylbutanoate, well, we have 1, 2, 3, 4 carbons with a methyl off carbon 2. All right, and of course our other one, our 1-methylpropylbutanoate, looks something like that as well. So that is the rest of our hydrocarbon derivatives. So there is a little diploma example or 2 on the back of these right here. So same thing, just kind of pause the video and try to get the answer, and then I'll put the answer out very shortly. But when we look at this one here, we have a structural diagram for vitamin E is represented below. So obviously this is massive. We are not expected to name this, but when we look at it, vitamin E can be classified as what type of organic compound, and it contains what functional group. All right, so if you want to pause and guess the answer, you can, but the answer is coming up in a few seconds. And we get the answer as B. So of course the aromatic is this one right here, so we can tell that. We know it's not going to be aliphatic, so we have the aromatic functional group that we can tell, and then of course the hydroxyl shows up right here. And finally, the herbicide 2,4-D is widely used for controlling broadleaf weeds. Its structure is known as the line formula below. So same thing as before, classify it and what functional group should it have. So the answer is going to go up in 2 seconds. And our answer would be D. Now, of course, the reason for this, if you did choose an ester, just look right here. So this is not an ester functional group because the ester functional group has that oxygen directly attached to the carbon with the doubly bonded oxygen there, whereas this one here, there's a carbon right here. All right, so they're not directly attached. That's why this is not an ester group, but we do see our carboxyl functional group right here. So that's why it is D, aromatic, because of the benzene ring and of course carboxylic acid. All right, so that concludes our hydrocarbon derivatives. So next lesson, we're going to look at the physical properties for these here. So try your workbooks. And of course, if you have any questions, we'll try to answer those through either A, email, or B, our next little Google Meet session where we can draw out some of these here and you guys can ask questions. All right, see you then.